It's another problem in the 4.1 maximum minimization problems. We were given the closed interval from negative pi over 3 to pi over 3 for our function negative 5 secant x. So what I wanted to do on this one in trying to solve it out, of course I needed to take the derivative and set it equal to 0 to find the critical points. We know any maximum or minimum values will be at those critical points or at the endpoints, negative pi over 3 and pi over 3. When I tried to set the derivative equal to 0, it was just either secant is equal to 0 or the tangent is equal to 0. When we know the secant's 1 over cosine, 1 divided by any number between negative 1 and 1 can never equal 0. So secant x equals 0 doesn't have any solutions, just means it doesn't contribute to any critical points. The tangent can equal 0 when the sine is 0. Since tangent sine over cosine, we know it's 0 when the sine is 0, and that would be at an angle of 0. So I can say, okay, x equals 0 is my only critical point. That leads me to set up my extreme value theorem right here. I can say I know that the only extreme values of this function on this interval are at the endpoints or at the critical point within those endpoints. So now I just evaluate all three of those x values into the function. Now, when I evaluate at negative pi over 3, negative 5 secant of negative pi over 3, I went ahead and graphed me a unit circle right here just to explain. At negative pi over 3, we know that the cosine component is 1/2, and we know it's going to be also 1/2 at pi over 3 up here. So the secant's just the reciprocal of that. I get negative 5 times 2 is negative 10. When I try to plug in a 0, well, the secant of 0 is just 1, since the cosine of 0 is 1, and the reciprocal of 1 is 1. Negative 5 times 1 give me a y value of negative 5. If you try to plug in a pi over 3, you get the exact same answer as negative pi over 3, since our secant at those angles are the same, which means both of these are minimum values. We would say we have a minimum of negative 10 at those angles, negative pi over 3 and pi over 3, and we have a maximum of negative 5 when x is 0. Good problem.